So I thought some of you might be interested in a little project I've been working on. Um, Binding an ukulele, putting the binding around the tops and the backs, can be a little harrowing. One of probably the most harrowing steps in building a guitar or an ukulele. When you're cutting those binding channels, there's a lot of room for mistakes and errors. When I reopened my shop, I had sold my cutters, my tower that I used for binding my guitars, and I thought I would try something different with the ukuleles being a little bit smaller. And I'm not totally unhappy with the setup that I decided upon, but I wasn't completely satisfied either. I started off with this jig right here. It's a Dremel tool that's used, and it's an attachment from StuMac that has a little guide on the side to guide it along the sides. And then you set the cutter, and it's got a little mini router bit, and it works pretty good on the top. It works very good on the top, as a matter of fact, but doesn't quite work as well on the back because of you see the narrowness in the front and the width on the top. You've got that radius on the back. The top is fairly flat on either ukulele or a guitar. Now my guitars, I built in a radius. I don't build a radius in the top of the ukulele, but I do build a radius in the back. So it's got a radius going front to back and a radius going side to side. And that causes some issues with tilting. And you have to keep the router bit and the instrument square to the side at a 90-degree angle, because if it tilts, and I'm exaggerating this a little bit, if it tilts this way, then you're cutting into the side, you're not getting the correct channel. So it was a little bit harder to cut the back side. So I went ahead and also had my Dremel tool that I used, which also works well, and you can cut a top channel and you can cut a side channel down on the bottom using the two different parts of the blade. You can see the blade here, you can flip it around and you can make those two cuts. And then this index is on the side, and it keeps it square to the side and works pretty well. But there's a lot more handwork and a lot more chance for error and slipping and jabbing that file into your hand. I mean, not the file, but the chisel into your hand if you're not careful. You don't get the accuracy that you do with a tower. So I decided to go back to a tower, and I started looking at the prices, and over the last 2 years, boy, have the prices of some of the tools that you buy shot up. So the piece that I was looking at from a well-known luthier company was going to cost over $330 plus to build or to buy the tower, the binding tower. So instead I decided to make my own, which is right here. And I bought the parts for this, and I spent maybe $75. Now that's pretty big savings, and it basically works on the same principle. You can see that the tower will rise when the instrument's in the cradle and sitting on here. As it's going around the back with the donut that's on the bottom, it rises and lowers as the radius rises and lowers. So it rides right on the edge. So it always keeps the cutter, which is right down in here, always keeps the cutter parallel to the side. So you get basically a perfect channel. There might be a little bit of sanding and maybe a hair of chiseling that needs to be done when you're finished, but not nearly the amount of time that it takes. So it's a lot quicker, it's a lot more accurate, and just takes that factor, that sweat factor out of the condition. So basically what I have here is parts that you would buy from a CNC machine. I've got a rail, this black piece over here. I bought a hunk of rail from a company called Open Build, and cut the piece to the length that I needed. The plexiglass that I used, you'd have to buy a piece of plexiglass, but unfortunately I had some pieces left over from old projects and everything that worked out perfect for building the base. So I just took the base off my router, cut the holes to match the the screw holes in the bottom of the router, cut a hole for the bit to come down through. And then on this spring that I've got on the back, you can see if I take it off, it'll drop right down. This spring is like a counterbalance, so it doesn't drop down as hard. It rides heavier, or rides lighter, I should say. Also, you don't have the full weight of the router riding on the instrument to give it any kind of tipping as you're moving around. So it's working fairly well. So I bought the rail. I bought what's called a gantry plate, and I bought a completed plate. On the gantry plate, there are four wheels that ride and keep it absolutely perfectly tight. There's an eccentric washer in here that allows you to draw the wheels in and out to tighten those wheels down exactly how they need to be, to keep the unit square. And then I guess the last thing, or the last couple things that I did was I bought a couple angle braces to hold it in place. I just mounted it on this little small piece of plywood that I cut out, scrap from my shop. And then I had some roller bearings, and I took a couple roller bearings and a piece of aluminum that I had, 1/8" aluminum, just bent it to shape, drilled the holes in it, drilled it into my unit, and it fits in very precise. Also have a little screw down here to keep things from falling down into the instrument and causing any kind of damage from the weight of that. So it only goes down a certain point till it hits that piece. So there you have it, $70. It's going to work absolutely as good as the one that they sell at the more expensive luthier stores for $300+. And so I saved myself a bunch of money, and now I've got a really accurate setup to cut my binding and purfling channels. So there you have it. I thought that might be interesting for some of you folks out there. I'll see you next time.